A box plot is a robust way of displaying information about a continuous numeric variable. We say that box plots are robust or display robust information because they rely on robust statistics not easily affected by outliers. In general, a box plot draws a box extending from Q1, the 0.25 quantile, to Q3, the 0.75 quantile of the data. That's the box shown here in this box plot graphic. It also shows a line between Q1 and Q3 that indicates the median or 0.5 quantile of the data. That's the horizontal line shown here. A whisker will extend from Q1, the 0.25 quantile, to the smallest observation that's not an outlier. That's this line shown here, extending from Q1 down to the smallest value that's not an outlier. A whisker extending from Q3 to the largest observation that's not an outlier. That's going to be this line shown here or this line shown here. And it also shows outliers, which are typically defined as an observation smaller than Q1 minus 1.5 times the interquartile range, which is defined as Q3 minus Q1, or larger than Q3 plus 1.5 times the interquartile range. And those are usually shown as dots, like in this graphic right here. So this is there's only a single outlier in this particular set of box plots. This particular graphic is an example of parallel box plots, which are an effective tool for comparing differences between a variable across multiple levels of a factor variable. So essentially what we do is we construct and display a box plot for each level of a factor variable. In this graphic, we're constructing parallel box plots of bill length distinguished by the species factor. So we once again start by creating a ggplot with the penguins data. We use the geom_boxplot geom to create a set of box plots. We map bill length underscore millimeters to the y variable in the box plot geometry, which is why the data are shown moving along the y-axis. And in order to get separate box plots for each level of the species variable, we map the species variable to the x variable in the geom_boxplot geometry. This code will produce the graphic shown here. So what do we learn from this graphic? We see that the bill lengths for the Adelie penguins tend to be lower than those for the chinstrap or gentoo penguins. The chinstrap penguins perhaps have slightly longer bill length on average than the gentoo penguins, but not by much. However, we see that all three penguin species have approximately the same amount of variability in their measurements, which is indicated by the total length of these box plots. A weakness of box plots is that they throw away a lot of information. So for example, we don't see the two subpopulations in the chinstrap penguins that we saw when looking at the density plots. To make this graphic slightly more appealing, we could add a fill aesthetic to the box plots while removing the legend using the following code. You see that we have similar code to before, but we also map the fill aesthetic to the species variable. And in order to remove the legend from the box plot, we use legend.position equals none in the theme function. While this doesn't technically add any new information to our graphic, it does make it a little more visually appealing.